What would you do with an unused brand new lithium-ion battery? The battery that was not charged even once. And discharged only once for not to blow up in this video. The answer is obvious: disassembly it. Let's disassemble the battery by cutting its aluminum envelope with scissors. Be calm, nobody ruins a perfect battery. This battery is defective. Its pouch is punctured, and it was delivered already damaged. The capacity of this battery equals to 600 milliampere. 2 such batteries were used to make almost everlasting Bluetooth headphones. You can watch the video on adding more batteries to Bluetooth headphones on this channel. Those headphones initially had a 200 milliampere battery, which lasted more than 20 hours. Imagine how long those Bluetooth headphones last now, when they gained a total capacity of 1400 milliampere. A safety warning. Do not disassemble any lithium-ion battery while it holds even a tiniest amount of charge. I mean seriously, it should be drained to absolute zero. Not the zero you see on the screen of the smartphone, Bluetooth headphones, laptop, or any other device you took the battery out. When the device shows 0% charge, the battery actually holds enough power to burn your house. Discharge the battery trough a 5 kiloohm resistor for several days until the voltmeter shows absolute 0 volts. Then drain the battery through a resistor for a day more. And only now it is safe to cut the lithium-ion battery open. Now, let's dive in the battery's internals. Internally, the lithium-ion battery comprises a positive electrode, cathode, made of lithium metal oxide, a negative electrode, anode, typically made of graphite. Both look like black powder. But one is on the aluminum foil, and other, on copper foil. Between 2 foils there is a separator that prevents direct contact between the electrodes while allowing ions to move freely. Everything is soaked in an electrolyte, enabling the flow of lithium ions between the electrodes during charging and discharging. The aluminum pouch encapsulation replaces the rigid metal casing you can see in cylindrical or prismatic batteries, as it offers several benefits. The pouch design reduces weight. Battery can be made thinner. The absence of a heavy metal casing allows more energy to be packed into the identical volume, enhancing energy density. Pouch cells are typically easier and cheaper to manufacture due to fewer structural components. However, pouch design does not offer a safety valve as cylindrical and prismatic metal-cased battery do. Meaning pouched batteries burn easier and require more attention. Thanks for watching. Click a like button to highlight this video for YouTube algorithm. Please subscribe to this channel to see more of such content.